Okay, Assalamualaikum and good afternoon. Right, this is the first round of the attendance. Okay, you can sign in the attendance based on the passcode given. And I'm going to open the second round of the attendance later on. So let's cover the topic 1. Okay, unfortunately my iPad is not working. I'm not sure why. So I'll just depending on my laptop. Right, so let's go on with lecture 1. If you look at here, you have computer system overview, right? So at the end of this topic, you guys should be able to describe the general organization of a computer system and also the role of interrupts, describe what are the components that are in the multiprocessor computer system, discuss on how operating system are used in various computing environment, and all these are basically aligned to your module learning outcome number 1. So this is a computer, this is a basic computer system. So basically in a computer, it consists of a CPU, or we can call it as processor. You have the main memory, you have the IO modules. IO stands for input and output. And also you have the system bus. So system bus is some sort of a pathway for the data to be transferred from one component to the other. And you have these elements, okay. Nope, not draw. Okay, so these elements are interconnected in some way to achieve the main function of the computer, which is to execute the programs. So these are the basic elements of a computer system. It contains the processor, the IO modules, the main memory, and also the system bus. So all these components are interconnected with the system bus, right? So first, let's look at the processor. The processor is the main or the brain of a computer. Without the processor, the computer won't be able to process the data and produce the information. So it controls the operation of a computer and it performs data processing functions referred to as the central processing unit, or in short, we can call it as CPU. So does anyone know what is the latest processor for Apple? What is the latest processor for Apple? Sorry? A17 Pro. And for Intel? What is the generation of Intel i9? What is the latest generation for Intel? Is it 14 or 15? Anyone knows? What is the latest generation for Intel i9 or Intel processors? If I'm not mistaken, it's 13 or 14. Okay, you can check through the website. Okay, if I'm not mistaken, the latest generation for Intel processors is generation 14 or 15. I might be wrong. Okay, you can check through the Intel websites. Okay, let's move on. So inside the computer, there is a main memory. So the main memory is volatile. Okay, it contains basically the definition of volatile means the content will be gone when you switch off the device or when you restart the device. Okay, so it is referred to as a real memory or a primary memory. So this is an example of a RAM. Okay, this is an example of a RAM. So for those who have not seen a RAM, a physical RAM, this is how the RAM looks like in your laptop. Okay, in your laptop. So if the one in the PC or the one in the desktop will be a bit bigger than the one in the laptop. So the one shown here is the one in the laptop. Okay, so IO modules, it moves data between the computer and also external environment, such as the storage. So when you talk about storage, you have the hard disk, okay, you have the flash drive, and etc. And then you have the communication equipment, and also you have the terminals. So the system bus, it provides for communication among the processors, the main memory, and also the IO modules. Okay, so like I said just now, the system bus, it provides some sort of link okay, or some sort of path to pass the data around the computer components. Okay, so we have three types of buses. Okay, we have three basic types of buses. One is the control bus, the other one is address bus, and the last one is the data bus. Okay, so inside a CPU, there are PC, IR, MAR, MBR, IOAR, and IOBR. And apart from that, there is an execution unit. So PC stands for program counter, IR stands for instruction register, and then we have MAR, memory address register, memory buffer register, and then we have IOAR and IOBR. So the CPU is basically interconnected with the main memory and also the I/O module through the system bus. So IOAR stands for Input Output Address Register, and IOBR stands for Input Output Buffer Register. So in the next few slides, we're going to see the simple fetch and execute cycle. Okay. So this is the explanation. All right. So it shows the top level components, and also it suggests the interaction between them. Then let's look at on the instruction execution. So a program consists of a set of instructions that are stored in the main memory. Sorry, not in the main memory, in the memory. So this is the basic, okay, this is the basic fetch and execute cycle. In the fetch and execute cycle, there are two main processes, which is the process reads the instruction from the main memory. So when the processor reads the instruction from the memory, it is called as fetch. Okay, and then when it executes, okay, when the processor executes its instruction, it is what we call as execute. So these are the two main processes that are in the fetch and execute cycle. Right, so let's look at on the next slide. Okay, so the two steps are referred to as fetch cycle and also execute cycle. So program execution will only halt, meaning that it will only stop for a moment if the machine is being switched off or some sort of unrecoverable error occurs, or a program instruction that halts the computer is encountered. Other than that, it will repeat this process over and over and over again. Okay, so this is the basic instruction cycle. Okay, this is how the basic instruction cycle of a computer system looks like. Okay, we have start, and then the instruction, okay, the computer system will fetch the next instruction, and then it will execute the instruction, and then this process will be repeated over and over and over again until it's being halt. So how does the halt happen? The halt happens when the machine is being switched off, some sort of recoverable errors, or the program instruction that halts the computer is encountered. Okay, so the processor fetch the instruction from the memory. Okay, the brain of the computer, it will fetch the instruction from the main memory. So the program counter will hold the address of the instruction to be fetched next. So that is the purpose of the program counter, which is what we call as PC. So the PC program counter will be incremented after each fetch. And if you look at this diagram, okay, there are 6 steps. So this is just a basic one, okay, not really an advanced one. So hopefully by giving out this simple example, you could understand on how does the fetch and execute works. So let's see on the next slide. Okay, I have some add-on slides. Okay, so if you look at this diagram, okay, this diagram illustrates a partial program execution, which means that it's just a simple one. It's showing the relevant portions of the memory and also the processor registers. So the program fragment shows it will add the content, okay, of the memory word at address 940. So if you look at here, you have the address at 940 to 941, okay? And then it stores the result in the letter location. And 3 instructions, which can be described as 3 fetches and 3 execute cycles are required. So let's look at step 1, step 2, step 3, and step 4 in quite detail. So for your information, PC stands for program counter, okay, and then IR stands for instruction register, and AC stands for accumulator. So PC is the place where we place, or the computer system place, the address of the execution. And then for IR, it is the instruction, okay, that is being executed. And for AC is just for temporary storage. Right, so let's look at step 1. Okay, so if you look at step 1, you have the memory address. Okay, so let me try to zoom in a little bit more. Okay, so you have address 300, 301, 302, and then you have 940 and 941. So this is just the address number. So these address numbers are in the memory. And then you have the CPU registers. So in the CPU registers, you have the PC, the AC, and also the IR. So let's look at the explanation for step 1. The PC, which is the program counter, it contains 300. So the address of the first instruction, meaning that the CPU register will have to pick up the instructions that is in the memory address 300. Okay, so memory address 300. And then the 1940 will go into the IR cell or IR space. So this instruction, which is 1940, is in hexadecimal format. What is hexadecimal? Hexadecimal is base 16. I'm sure that you guys have learned mathematics. So hexadecimal is in base 16 format. So the 1940 will be loaded into the instruction register, or we can call it as IR for short. And then once the 1940 is being loaded into the IR, the PC will be incremented by 1. So in the next step, the PC will become 301. Okay, so that's what happens in step number 2. Note that this process, the one that being shown here, is just a very simple one, okay, without the involvement of memory address register, or MAR for short, and also memory buffer register. So this is just for simplicity. Okay, this is just for simplicity. So all these registers, okay, all these two registers are being ignored for this explanation. All right, so that's what happens in step 1. And then for step 2, you have address 940, okay? Address 940, and this is the content, or this is the instruction. So this instruction will go into the AC, okay? And then if you look at the explanation, so the first 4 bits, okay, which is the first hexadecimal digit in the IR, is indicating that the AC is to be loaded. And then the remaining 12 bits, okay, in the data, which is the 3 hexadecimal digits, will specify the address, which is 940, from which data is to be loaded. Okay, so that's how you get the data from 940. Okay, and then for step number 3, okay, the next instruction, which is 5941 in hexadecimal format, all right, it will be loaded into the IR, which is the instruction register, okay, and the PC will be incremented. So this is what happens in step 2 previously, okay. And then if you look at step number 4, the old content of the AC, all right, so previously the AC was 0003, and then it will be removed and it will be replaced with 0005, which is the content of location 941 to be added, and the result will be stored in the AC. Right, so basically 3 plus 2 is 5, so 5 will be stored in the AC. So AC is only used for temporary storage. Okay, AC stands for accumulator. All right, so let's move on. So in step 5, the next instruction, okay, which is 2941. Okay, so 2941 is located at memory address 302, will be fetched, all right? And the PC will be incremented from 302 to 303. So if you look at in step 6, the PC value has been increased from 302 to 303. So now the content of AC, which is the accumulator, will be stored in the location of 941. Okay, so this is just a simplified explanation of what happens during the fetch and decode cycle. Sorry, not decode. Fetch and execute and decode cycle. Okay, based on this specific example. All right, so I'll share the updated slides in the My Times later. Okay, don't worry. Okay, so let's move on with the next one. So you have the instruction register. Okay, so instruction register known as IR. It fetch, okay, the function of IR is to fetch the instruction that is loaded. So processor interprets the instructions and will perform the required action, which is the processor memory, processor I/O, data processing, and also the control. And then we have the computer system operation. I/O devices and the CPU can execute concurrently. Each device controller is in charge of a particular device type, and I/O is from the device to local buffer of controller. So in the I/O, there are 3 basic techniques. I'm sure that you guys have learned this when you took computer architecture or computer organization. So these 3 techniques are known as program I/O, interrupt-driven I/O, and also direct memory access DMA. So these are the 3 possible techniques for I/O operation. And let's look at one by one. So program I/O is where the I/O module performs the requested action, and then it will set the appropriate bits into the I/O status register, and then the processor will do a periodically check on the status of the I/O module until it could determine when the instruction is to be completed. Okay, so with program I/O, the performance level of the entire system is severely degraded. So this is the flow chart. Okay, this is the flow chart of a program I/O. So you have issue read command to the I/O module, and then what happened next? It will read the status of the I/O module. Okay, so if it's not ready, then it will repeat the process. If it's ready, then it will read the word from the I/O module, and then it will proceed with the right word into the memory. So if it's not done, it will repeat the whole process, and if it's done, then it will move on to the next instruction. So that is what happens during the program I/O. So let's look at the explanation. So an example of the use of the program I/O is to read a block of data from a peripheral device. So does anyone know what is peripheral device? What is peripheral device? Anyone? Okay, so peripheral devices is the input devices like your mouse, your pen drive, and etc. Okay, so in this example, record from tape into the main or into the memory. So the data from the record, okay, or from the tape, is read in one word. So what is the size of that one word? It is 16 bits at a time. Okay, so 16 bits is equivalent to 2 bytes. So for each word that is read in, the processor must remain in a status check-in cycle until it determines that the word is available in the I/O module data register. So if you look at this flow chart, it highlights the main disadvantage of the program I/O. So what is the main disadvantage? It is time-consuming process that will keep the processor busy at all time. So that is the disadvantage of program I/O. And then we have the interrupt-driven I/O. Okay, so let's look at the flowchart instead. Okay, so it shows that we use interrupt I/O for reading in a block of data. So interrupt I/O is more efficient if we compare to program I/O. Why? Because however, I will go through that later. However, the interrupt I/O will still consume a lot of processor time because of every word has to go into the that goes into the memory, from the memory to I/O module, or from the I/O module to the memory that has to be passed through the processor. Okay, so it will still consume time, but it is much the time consumed is much shorter compared to the program I/O. Okay, so if you look at here, issue read command to the I/O module, and then you have the read status of the I/O module, so it will check the status, and then if it's ready, then it will read the word from the I/O module. If it's not ready, then it will show some sort of error condition message, and then it will write word into the memory, and then if it's done, it will proceed to the next instruction. So this is how the flow of an interrupt-driven I/O. Okay, so if you compare with the program I/O, it is much simpler compared to the program I/O. Let's look at on the, we're not going to cover that. Let's look at on the direct memory access, or DMA for short. So for the DMA, it will skip, it will not go through the processor. It will not go through the processor. So how it works? It performed by a separate module on the system bus or incorporated into an I/O module. So when the processor wishes to read or write the data, it will issue a command to the DMA module containing whether the processor is going to write or read based on the requested information, and then the address of the I/O device involved. Okay, so what are the addresses involved, and then the starting location in the memory to write or to read, and then the number of words to be read and also written. So this is the flow chart for DMA. Okay, direct memory access. It doesn't involve any processor. So transfer, it will transfer the entire block of data directly to and from the memory without the need to go through the processor. So the processor, in this case, the processor will only involve at the beginning and also at the end of the transfer. And the processor executes more slowly during a transfer when a processor access to the bus is required, and it is said that it is much more efficient compared to the interrupt-driven and also the the program I/O. Okay, so that is in terms of the I/O. Okay, the I/O techniques. So later on, if I ask you what are the I/O techniques that you can use for I/O operations in your midterm or in your final exams, so these are the things that you have to answer. Okay, so there are 3 techniques. We have program I/O, interrupt-driven I/O, and also direct memory access. Okay, so let's move on with the next topic. Okay, so we have the memory hierarchy. Storage system organized in hierarchy. So we will look at in terms of the speed, the cost, the volatility, or the size. So if you look at this pyramid, okay, let's try to zoom in. Okay, let's try to zoom in. So the in-board memory has the highest ranking. So inside the in-board memory, there is register, there is cache, and also there is main memory. Okay. As for the second level, we have the outboard storage. So for the outboard storage, we have storage. We have storage like magnetic disk, CD-ROM, CD, DVD, DVD RAM, and also Blu-ray. So does anyone know what is the difference between DVD, CD, and also Blu-ray? Anyone? Anyone knows what is the difference between CD, DVD, and Blu-ray? What's the main difference? Okay, in terms of size of the storage. Okay, so that is the main reason. That is the main difference. So what is the maximum capacity of a Blu-ray disc? Does anyone know? What is the maximum capacity for the Blu-ray disc? No? I also don't know, that's why I asked. Okay. Anyone knows? Okay, so I'm not sure. Okay, you can find in the market, but I think you can go up to, is it 70? I'm not quite sure. Okay, you can do some research. And then we have the third level, which is the offline storage. So the offline storage is the magnetic tape. Okay, so going down to the hierarchy, it will have decreasing cost per bit, increasing capacity, increasing access time, decreasing frequency of access to the memory by processor. So if you notice, okay, as it goes up to this pyramid, the price of the main memory, okay, is much higher compared to the price of the Blu-ray. Do you agree with me? Okay, so what is the highest RAM that you can get for a laptop nowadays? Is it 32? Can you get it for 64? Yes, for laptop. Okay, how much did it cost you? Do you know how much is the price for 64 gig RAM? Is it more than 500? About that, more than. Is it less than 1,000? More than? Seriously? Okay. So I'm sure that if you are if the laptop is using 64 gig of RAM, how about the processor? i9 or i11? I think it's i11. No i11. Oh, sorry, i7. Sorry, i9. Okay, i9. All right. So what's the price for i9 processor? 10,000. Okay, so in total, maybe for this cost of a computer, it will cost you about 15,000 maybe? Less than that. Okay, so it depends on the specification, right? So based on your friends, the highest RAM or the highest laptop RAM that you can get nowadays is 64 gig. Okay, 64 gig of RAM. All right, so that's just for information. And then we have the cache memory. Okay, so we have the cache memory. What time is it now? Okay. So for the cache memory, we have a single cache, and also we have a 3-level cache. Okay, so let's look at the explanation. All right, so the cache memory, okay, for a single cache memory, it is designed to combine the memory access time of expensive, high-speed memory combined with a large memory size of less expensive and also the lower speed memory. So you have a CPU, okay, which is the processor, and then you have the main memory. So the cache will be located between the CPU and also the main memory. So most of the programs that you run, or most of the frequent data or the frequent program that you run will be stored in the cache memory. Okay, so this is the single cache. And then you have a 3-level cache organization. So basically, if you have 3-level cache organization, there will be 3 levels of cache memory, okay, between the CPU and also the main memory. So if you look at this, okay, it shows you the multiple levels of cache. So you have the L2 cache. So for the L2 cache, it is much slower and it is typically much larger than the L1 cache. And the L3 cache is slower compared to the L2 cache and typically larger than the L2 cache. So this is how they arrange the cache memory in terms of the 3-level cache organization. Okay, so then these numbers, it shows if it's lower, then it shows that it is nearer to the CPU. Okay, so that's how the cache memory works. And then we have characteristics of various type of storage. Okay, so we have okay, you can go through that. So movement between levels of storage hierarchy can be explicit or implicit. And then we have the multi-programming. Okay, multi-programming. So single user cannot always keep the CPU and I/O device busy. So this is where the multi-programming comes in. The multi-programming will organize the job, which is the code and also the data. So the CPU will always has one to execute. So a subset of total jobs in the system is kept in the memory, and then one job is selected and run via the job scheduling. So when the job has to wait, for example, I/O, the OS or the operating system will switch to another job. So, okay, and then we have multitasking, which is time sharing. The CPU switches jobs so frequently that users can interact with each job while it is running. Okay, so the virtual memory will allow execution of processes not completely in the memory. All right, so let's look at on the symmetric multiprocessor. Sorry, I have to speed up because it's already 12:40. I don't think 1 hour is enough for the lecture, but never mind. So a standalone computer system with the following characteristics. There are 2 or more similar processors of comparable capability. So processors share access to I/O devices, or processors can perform the same functions, and the system is controlled by an integrated operating system that provides interaction between the processor and etc. So if you look at this, this is a symmetric multiprocessor organization. So in the symmetric multiprocessor organization, you have a number of processors, okay? So you have the first processor, you have the second processor, and also you have the end processor, right? So all these processors are connected with the I/O subsystem through the system bus, and also these processors are connected to this main memory through the system bus. And if you look at here, in the I/O system, in the I/O subsystem, there are a number of I/O adapters, meaning that there will be quite a number of I/O peripherals. Okay, I/O peripherals. Okay, so next is multi-core computers. Okay, so also known as chip multiprocessor. It combines 2 or more processors, or we can call it as cores on a single chip. So each core consists of all components of an independent processor. And in addition, multi-core chips also include the L2 cache, and in some cases, there is L3 cache. Okay, so in the processor, itself, it also contains the cache memory. Okay, so you have this processor. So inside the processor, there are cores. So how many cores does the i9 or i7 has? Does anyone know? Okay, so let's look at the website. Okay, let's look at the website of Intel. Okay, so Intel processor. Okay, so we have, let's look at the latest generation. So let's look at i9. Okay, so let's look at the product or the documentation. So let's look at the product. Okay, so if you look at the product, okay, for i7, maybe it's not quite big. Okay, so for i7, the latest generation is 14th. So for i7 14650HX, it contains 16 cores. Okay, and for i7 14700HX, it contains 20 cores. So meaning that if we refer to this diagram, inside of those processor, okay, it has these 20 cores lah. Okay, so in the core, it contains the registers and also the cache. So as you can see here, in the multi-core chips, there are the L2 cache, and some of them, there are L3 cache. So let's look at this information again. Okay, let's try and go into that thing. Okay, so as you can see here, the total number of cores are 20, right, for i7 14th generation, and that is the recommended customer price. Okay, so it's in US dollar. And then you have the total thread of 28 threads. And for the speed, okay, in terms of frequency, it is 5 gigahertz. Okay, and then the total number of cache for this specific model, which is i7 14700F, is 33 MB Intel Smart Cache. Okay, so there are 33 MB of Smart Cache. So total of L2 cache is 28 MB. All right. So for this processor, there's no L3 cache. There's only up to L2 cache. Okay, so that is the size of the L2 cache. All right. Okay, so let's look at that. And then the processor is connected to the main memory through the system bus. So this is how the design of a dual-core processor. Okay, so the one that I showed you just now is not dual-core. Okay, it is much higher. All right, so computing environment, we have traditional mobile, client-server, peer-to-peer, cloud computing, and also real-time embedded. So traditional is a stand-alone general-purpose machine, but blurred as most systems interconnected with others. Then you have portals, network computers, thin clients are like web terminals. Mobile computer interconnect via wireless network, and also networking become ubiquitous. Okay, and then we have mobile. So what is mobile? It's a handheld smartphone or tablets. And what is the functional difference between them and a traditional laptop? So what's the functional difference between a mobile and also a traditional laptop? Anyone knows? What is the functional difference? No? Okay, so extra feature, okay, you have more OS features like the GPS and also the gyroscope. So what is the function of gyroscope? Sorry? To detect the movement of your device, is it? Okay, and then allows new types of apps like AR, augmented reality. So you have IEEE 802.11, wireless or cellular data networks for connectivities. So we have leaders like Apple iOS and also Google Android. Okay, and then we have the client server. Okay, we have the client server. So the client server computing is a dumb terminal replaced by smart PCs. So many systems now, which is the servers, responding to the requests generated by clients. So the computer server system provides an interface to the client to request services such as the database And then we have the file server system, provide interface for client to store and also to retrieve the files. So you can imagine the client server system something like this. Okay, so you have a server. So this server is connected to a network. Okay, and then this network is connected to the client desktop, which is the PC, or the client laptop, or the client smartphone. Okay, and then we have the peer-to-peer. So it's another model of distributed system. P2P does not distinguish client and servers. Instead, all nodes are considered as peers. Okay, so instead of all nodes, may each act as a client and also server for both. So node must join the P2P network. Okay, so this is just an example of a P2P. Okay, so this is P2P, client and client. So this is P2P, and this is P2P as well. So what type of topology is this? Are you sure it's star? It is not star topology. Okay, it's not star topology network. It is a mesh topology network. Why is it called as mesh? Why is it called as mesh topology network? Okay, it has a lot of redundancy connection. So basically, if this link is down, okay, the data can be transferred through the other link. So that is why it is called as mesh topology network, where we have a lot of redundancies connection. And then you have cloud computing, okay, delivering computing, storage, even apps as a service across a network. So logical extension of visualization because it uses visualization. And there are many types of cloud computing, such as the public cloud, private cloud, hybrid cloud, and also the software as a service, or SaaS. And also we have the platform as a service, IaaS. So all these include the Amazon or AWS, Azure, okay, Azure, how do I pronounce this? Azure, and then we have Alibaba, and also we have the Google Cloud. Okay, I think this is real-time embedded system. Okay, most prevalent form of computers, very considerable, special purpose, and also it has a limited purpose OS, real-time operating system. So the use is expanding, and many other special computing environments such as, as well, some have OS, some perform tasks without an OS. So the real-time OS or operating system has well-defined fixed time constraint. Okay, and then I think that's all for this topic. Okay, so I'm going to open the attendance again for the second time. For those who have missed the first round of the attendance, please key in your attendance. All right, so, okay, any question that you guys want to ask before we end the lecture session? No? Okay, so for session 3 to 4, I'll meet you guys at E what? What's the venue again? For, okay, never mind. I'll see you guys at 3 to 4 for those who are having the replacement session. Okay, so thank you very much. You can dismiss.